The title of this research is Investigating the Nature of Designerly Learning in Technology Education. To provide background, there has been a recent junior cycle reform, and within this reform, design is made an explicit component of technology education, where previously it was somewhat implicit. Now within all 4 subjects, design is an explicit aspect and acts as both a process by which students learn and also an outcome of learning too. This causes an issue from the point of view of differing perspectives and opinions and views, and maybe somewhat lack of understanding as to how design manifests when it is used in the context of learning in technology education, and something that teachers can use practically to go about their practice. This leads to the research question: how does learning manifest through designerly activity in second level technology education? Naturally, this leads to the aim of gaining an understanding of how learning manifests when students engage in designerly activity, and the specific objectives, which are to determine how the inherent capacity of the learner to design and the associated learning outcomes in technology education manifest during design activity in technology education, to look at how different aspects of what is significant to learning interact with one another while they go about learning through designerly activity, so applying and acquiring knowledge, the capacity to learn, and also modeling, which is so central to designerly activity. And also this research seeks to develop a method to capture learners' designerly activity through the lenses of their capacity to learn, so relating it directly to learning and seeing what can be used or what way we can capture that learning and that related aspect between the factors that are important for learning, the acquisition, application of knowledge, the capacity to learn, and the use of modeling, and how we can actually capture that, how we can observe that. And lastly, it's important for this research to be able to determine the learning that results from learners engaged in designerly activity in technology education. So what is the explicit learning outcomes that can be achieved by a practitioner when students engage in designerly activity in the classroom? The working definitions are important to point out here because designerly learning is somewhat of a kind term. And to begin with talking about being designerly, it's essentially the human, and this is a synthesis of work from previous decades, but it's the inherent human capacity, human activity of modeling potential changes in the made world, which is both a natural predisposition of humans and also something that is societally beneficial. It manifests in technology education when students are presented with a task or a problem that they need to solve, and they act designerly in that way when it's an open-ended or even somewhat closed-ended task. They act designerly. Therefore, designerly learning is drawn from this within a context of learning and with more of a alignment with learning, which is that learning through design activity in technology education by modeling and or realizing change in the made world is what is defined as designerly learning. This is the process under which learners in technology education develop capability through engaging in designerly activity. So a very explicit reference to development and learning. To start to review the pertinent literature, this literature all works towards conceptual frameworks. And this will be presented now just to break down what is important with each, and then will be synthesized through the frameworks at a later stage in the presentation. So Geary proposes 2 knowledge types, essentially our biologically primary knowledge and biologically secondary knowledge. Our biologically primary knowledge is knowledge that we learn and we acquire naturally over time, just simply through exposure to stimuli. For example, our first language, we acquire the ability to use our first language naturally. Biologically secondary knowledge, on the other hand, is something that we need to be taught, or we just need to put explicit effort into learning. It's not acquired naturally. It's often seen that schools are the primary place where students acquire biologically secondary knowledge. Even the fact that there are 2 types of knowledge that can be learned naturally without effort and just simply through exposure, and knowledge that requires effort to learn, is important for us because design is often perceived and proposed to be an innate capacity. It's inherent to humans. Therefore, there's an aspect of that which would be arguably biologically primary knowledge, but much of design that is relevant today, for example, with the vast knowledge that humans have acquired over time, like materials, properties, aesthetics, functions, forms, mechanics, physics, these other considerations that play a part in different subjects and different extents is significant. So we can say that designerly activity, when it comes to learning, needs to be considerate of these two perspectives on knowledge. And when we speak about knowledge, we need to speak about memory, because knowledge is what you learn, whereas memory is how you learn. Working memory is where we do all the work of managing information and working with information. When we are thinking, it is our working memory that is in use and it is active at the time. Long-term memory is where our learning goes to, essentially, where we learn information. And when we work with information in our working memory and we work with it effectively, we can commit that then to long-term memory. And once it is committed to long-term memory, that is what is often used as a definition of learning, something that is committed to long-term memory, because then you can remember it and retrieve it at a later date and bring it into your working memory for later use. Long-term memory is essentially an infinite store, but working memory is limited, and the limited capacity of working memory is very important, as well as the interaction between long-term and working memory. This limited capacity of working memory is often used in the construct of cognitive load, and this concept of cognitive load, which is often used in educational settings within and beyond technology education, and essentially speaks to the fact that increased cognitive activity and cognitive demand on an individual increases the load, and it uses up that limited capacity of the working memory. And that's important to consider. Within our subjects, it's important for us to be considerate of the fact that if students just simply think and don't externalize, then that might create a great deal of cognitive load. And the externalization actually allows for that cognitive load to be relieved on them and to be held more so in the environment. So instead of working with a spatial information just purely in the head, if you were to sketch it or even to model something in a 3D manner, that would offload some of that cognitive load, which is important. And it's particularly significant when it comes to the management of dealing with uncertain knowledge or uncertain situations, when it comes to modeling problems, modeling solutions. This could be proposed as a way of understanding the significance of and the benefit that students get from externalizing their thinking and confronting reality outside the head, as we see in this Kelly et al. Paper from 1987, then used by the APU. So the centrality of modeling is significant, and it's significant to the management of cognition and management of learning. But we also need to talk about how modeling is not always necessitated by load. Modeling has more of a purpose than just simply managing cognitive load. It also may be appropriate due to the lack of knowledge to grapple with the problem at hand. Students may also model as a result of being able to just use that information in a more effective way, or work with that information in a more effective way than they were in their head. Not because they were finding it particularly difficult, but it just manifests better, and then they can automatically critique it better. So essentially, modeling, as is proposed here, is at the interface between memory and knowledge. And within technology education, and specifically designerly activity in technology education, modeling is essential because of that interface and because of that mediation between the two, which leads directly into our conceptual frameworks. Firstly, the conceptual framework of treatments of designerly learning. This framework breaks off designerly learning into learning to design, learning by designing, and learning about design. It works both vertically and horizontally. And just to work through it vertically first, if we look at learning to design develops capacity to enact developed capability. Essentially talking about how learning to design gives you the skills to better enact the inherent capacity you have to design, as well as also being more effective in your designerly activity. Learning what needs to be considered, learning aspects of critique and consideration of what's needed from design, working within constraints and working with uncertainty. Learning by designing affords management of the application of capability. This is essentially drawing back to the idea of biologically primary knowledge, where we do have an inherent capacity to work with information in a designerly way, and to ideate in a designerly way and act in a designerly way. And this makes students, or exposes students to that experience more, allows for them to manage that experience more effectively and manage their skills and become more aware of their skills in that area, to allow for the application of that learning to design aspect more effectively. And a learning about design is somewhat of a a new area that is not commonly referred to, but really does capture everything within the remit of what way design manifests in technology education when it's added. So learning about design informs philosophy of potential of capability. So students learn about the field of design, they learn about the capability of design, they learn about the remit of design, they learn about what it has done in the past and how it has done it, and what it can do. They get an appreciation and an effective appreciation for what the capacity of design is. It also operates in a horizontal way. So we've got knowledge and skills at the top on two different ends of a continua. Learning about design is definitely knowledge about design, and learning to design is definitely skilled in the area of design and enacting design. We've got from abstract to concrete. So abstract is more so a philosophical perspective, as we see here, and capacity is more of something that's tangible, something that you can actually grasp onto and you can understand and you can see somebody applying. And also, for this particular example, speculation and action are two ends of the this continuum here on the bottom, where speculation is for potential, to speculate on the potential of something, and then application becomes more towards action. Even with that, you're considering the action of what it would mean to actually enact a potential solution, and then enacting the potential solution, enacting what can be done or what may be done, is where it hits the ground, and that's where it maybe transitions to outside the head. So actually being active and having action on your ideas and not being passive with them is an essential part of treatment of designerly learning. Now, the conceptual framework that's let's say most related to the ideas of memory and knowledge and memory, knowledge and modeling is this one. This is where these come together in the form of activity. The previous one was in a macroscopic view of how design learning can be treated from a kind of an organizational structure and used subsequently in the methodology. But this one is very much so related to the activity of the student. You can see that biologically primary knowledge and biologically secondary knowledge are vertical. These are long continua. Mediums of modeling and embodied, embedded, and extended cognition, which are essentially forms that take advantage of the fact that externalizing information can reduce cognitive load, but also can more effectively allow students to work with information, work with complex information, or just work with more information, work with information that's more aligned with externalization. Long-term memory and working memory work together in that your working memory is where you deal with information, long-term memory is where you commit it. These work along a continua as we're proposing here. There's no specific split gap between them, even though they are categorically different. For example, long-term memory and working memory, we need to understand them as a continua and see how they work together and interchangeable with each other. Considerations for learning is all that's on the top. So considerations for learning outcomes in terms of long-term memory, that commitment, mediums of modeling, and biologically primary knowledge. So what can you actually teach them and what can you not teach them? Considerations for learning activity then. What about their prior knowledge? What about their biologically secondary prior knowledge? What about their embodied, embedded, and extended cognition capabilities to work with information as they act in a space of maybe uncertainty or trying to understand something or trying to ideate something? And working memory, the limited capacity for them to think in a certain way or think about a certain amount of things and how that affects the efficiency with which they learn is essentially at the core of any activity. But the thing is that these are relevant to really any subject in any area. The thing about design and the treatment of design is the way that it makes these merge into a form which is more considerate of bandwidth. And this bandwidth here is what can be limiting to the learner's experience. Given the fact that the design is innate, they naturally learn from designing, or they naturally learn how to design, but also there's aspects of it which is learnable and teachable as well. The fact that there's modeling involved here, and that's at the interface of both the knowledge and the memory systems, the limited aspect of working memory. This is really essential because to get this working effectively and to get a good understanding as to how students learn, we need to develop our understanding as to how design needs to manifest in the context of learning, or else there may be a bandwidth issue. And if there is, we can at least identify it within particular individual students where they might lack knowledge, they might lack some cognitive capacity to work with modeling so that they actually get use out of it, or where they can work, or where they might lack some working memory capacity because they lack in some other area an understanding of something that was not considered. This bandwidth is essential to consider when we speak about the treatment of design. This moves on to the methodology, and the methodology is conceptually driven, and it speaks directly to both models. So model 1, it frames the design of lessons and tasks with the teacher, and this is very much so uses a common space of interaction so that we both have a common space in which we can understand what is happening, me being the researcher, him being the practitioner. It also provides a framework for understanding activity through learning. It links observed activity to its affordance to developing capability. In Model 2, this is directly related more so to the actual student activity as it may be observed. As a result, it's a lens through which to view observed activity. It operationalizes the observation of activity. It directs purpose of the design portfolio, and design portfolio was based upon this model and design on the basis of this model. And also it's informing the way that we collect data and what data needs to be collected as a result of the understanding that these are important for learning within design-early learning. And this is the point at which that has been done. What I've just spoken about has been established and has been worked through. This is where I start to talk about future work. And this study will begin in September, and it deals with the manifestation, interactivity, and method of capture. So essentially objectives 1, 2, and 3 for the research. It's primarily qualitative, but it is mixed methods. It's primarily qualitative because the student voice is essential within this. The methods of data collection during the task are video recording, and that is qualitative, paper and pencil recording, qualitative, so recording their sketches and their notes and so on, and task load recording, so the NASA TLX, so the effort, the frustration maybe that they might feel, the temporal demand that they might feel, the cognitive demand that they might feel. This is quantitative and acts as a way of maybe categorizing students at particular points of the process and using that to be able to shed light and to color the way that we look at the qualitative data. It may be a good way to differentiate between what we observed. The retrospective task then, so retrospective to the task, just after they've completed the task, a video stimulated recall interview will be carried out where questions such as, give me a justification for the solution that you come up with. Why do you think that this will solve the problem? Why did you change from discussing this with your friend to sketching? These are particular points of interest, and the particular questions will only become apparent and justified through reviewing the video data for each individual student if it can't be understood or explained from observation. Study 1 task workflow then looks like this. It's on page 32 of the thesis, and the teacher activity is what's, let's say, guided here, and it's given in column 1. So the student activity is outlined in column 2. The portfolio prompt then is given in column 3, which at the moment is just simply a blank piece of paper in which they are prompted to respond to text at the top, or prompted to respond to it on the basis of what the teacher gives them to ask them when the teacher asks these questions. The investigative intent and lens is the justification behind each of the teacher's remarks, the student's activity, as well as the prompts within the portfolio. Why am I getting them to do what I want them to do within the portfolio? Why am I getting them to respond in this way? And also the use of the TLX at particular points. And this is a justification through the lens of that second model of memory, knowledge, and modeling the whole way through. Then study 2, it's very much so determining observable learning, and learning is at the center of study 2 because within study 1 learning was assumed and it was looking at the factors. So it was looking at learning, knowledge, or memory, knowledge, and modeling, whereas study 2 is assuming that there's memory, knowledge, and modeling interactions based on the findings from study 1, but realistically it's more so aligned with looking at how this interacts with learning and how these play when you consider learning. It's all about evidencing how these factors investigated in study 1 interact and contribute to learning. It will incorporate the following methods when justified. So when we find good reason within study 1 and what we observe in the study 1, and this is not an exhaustive list, will include comparator, so the NASA task index, so the task load index from NASA, compares student activity during the task, holistic to look at it holistically, to look at their assessment, the assessment of learning, maybe through ACJ as a medium to students get them to do it themselves, as a differentiator, to be able to differentiate students on the basis of, let's say, their spatial ability or working memory capacity or fluid intelligence may be useful here. And look at their efficacy, how well they think they did themselves. So learner self-reporting, the degree of learning that they experienced is significant here. These studies work with each other, and while sequentially they are important, holistically they are also important. Bidirectionally they work together, because after study 1 is completed, it informs what may be possible to be done in study 2. And when study 2 is completed, it will give a different understanding and a different perspective on the findings from study 1. So they speak to each other in both ways, both sequentially and also at the same time. The contributions of the research then center around understanding the manifestation of factors that are associated with learning, the interactivity of those factors, being able to identify the learner's needs as a result of identifying the manifestation and interactivity of those factors, and also seeing what learning manifests and see what resultant learning manifests, which may act as a guide to see what should be aimed to be accomplished within classes, within technology education, and hopefully bring some clarity to the application and the enrollment of the employment of the new junior cycle syllabi. This is work resulting from this research so far, 3 conference papers and 1 journal article in review. And this is the operationalization of the studies and also the completion of the thesis in conjunction with the publication of papers.